Hi, this is an introduction to the new AI integration that we've added to the Undo for Java product. Just to recap, Undo records programs at the system level, enabling exact replay and reverse debugging of applications in any language, including Java. So we've added a new lr4j MCP command, which allows AI tools to interact with the recording via MCP. And it offers all the usual time-travel debugging operations that our IntelliJ plugin supports, plus some additional native capabilities such as C-level breakpoints and stacks, raw memory access, and object tracking. There's also a Python API to save operations, which allows Claude to create a Python script for more in-depth analysis. Okay, so now we're going to use Claude to debug a concurrent modification exception. It's a good example of time travel debugging because you need to go back in time to find the offending thread. And here's the code, which is fairly straightforward. Note, we only need to ask it once, and Claude then uses its own knowledge of Java internals to find the root cause. So we ask it to go ahead and find the concurrent modification exception. And from here on, it just goes and does it. We don't interfere. So it's reading the console lines, and it sees a message to say there's been a concurrent modification exception. So it knows to set an exception breakpoint. Which it does. And it analyzes the stack. It's reading the source code here. This is with access to the source code. We'll have another test a bit later without access to the source code. So it's figured out the cause. Now it's going back in time even further to find out what modified this array list. So it's set a watch point on the mod count. Sets a watch point, does a reverse, and then it can see which thread actually modified that array list and the exact location. And there it is. There's its analysis of the root cause. So now we're going to, just for fun, we're going to try the same thing again, but without access to the source code. So we've removed the source code, and Claude, this is fast forwarded by the way, this is Claude just doing the same thing, but blind. It just uses the MCP commands and its knowledge of Java internals. We can also ask it where this array list was created. And it uses that using go to object create, which lets it go back in time to find out where an object was created. That uses watch points in the object header, by the way, to track across multiple GC relocations. So now we're going to look at how we can use Claude to coordinate amongst multiple processes. So we're going to look at microservices, and in this particular example, we're going to look at PetClinic, Spring PetClinic microservice version, which has been broken down into a number of separate processes. We've got API gateway, which is what the user talks to via REST requests, and that talks to a number of other microservices, including customer service. So we're going to record the API gateway and customer service, and this is the web interface. You click on an owner and it shows details of it, and we've introduced a bug into when you click on Peter, if the owner's name is Peter, then it throws an exception. So having recorded them and got Claude talking to both MCP servers, one for each recording, we ask it to read the console lines and see if it can find any errors, which it does. And it comes up with, it finds the exception that's been thrown and timestamp and details of what the error was. So what we're going to do now is we're going to ask Claude to go to that timestamp -1 second. The reason for that is just because timestamps are a kind of rough estimate of where you are, and so we want to set a breakpoint in get owner details, which is the thing that processes the request, and resume to it. Note that we don't need to go into details with Claude about how it does all this. It just knows from the MCP command descriptions. So it sets a breakpoint. It goes to the timestamp. Sorry. Then it sets a breakpoint and proceeds to it. And I've asked it to display the code at the point. At this point. And the next thing we're going to do is we're going to go over to the customer service microprocess, and I'm going to go to the same timestamp and then set a breakpoint where the call is handled. Claude obviously knows how to do all this because it's got access to the source code, which it does. And there's the source code for the find owner thing, and you can see the bug that we've introduced there. So we're going to ask Claude to step through to the error. But Claude knows how to use MCP commands to do single stepping. So it steps through, and there's the runtime exception being thrown. Now we're going to look under the Java hood and get Claude to search for and print out the contents of the socket write on the API gateway. Again, don't need to spell out in details how to do all this. Claude figures it out from the MCP commands. So it finds the socket write. It actually ignores one or two other writes that are not to sockets. So it's able to figure out which is a socket write and which isn't. And then finally it comes up with the buffer, and there you can see that's a normal HTTP request that's being sent across to the customer service. We can do the same thing on the other side with read calls, socket reads. So we set it off, and very quickly it comes back, and as you can see, there's the exact same request on the other side. And finally, we've just asked it to display the native stack at the point where the socket read occurred. More demonstration of the kind of native capabilities that we've added that go beyond just Java. This is a simple little program that just prints out strings, and we're going to search the recording for a given string. So we're going to ask it to use binary chop on the Python API. So we want to search the recording for the string where is Wally on standard out, and It's going to take a little bit of time because it's using binary chop across the entire recording to find out where that string first appeared in memory. So this is it. It's reading the Python API source code to figure out what it's got available to it, and it creates a Python script, as you can see, to do the binary chop. And then it executes it. And again, I've fast forwarded this a little bit. Just takes a minute or two. And then it outputs the exact location, the exact BB count where that string was created. So I'll just display the source code here. Slash code, by the way, is just something that I added to display Java code around a given location. And there you can see line 67 is where that string was created. It's quite handy because sometimes you have strings and you don't know where they came from and you want to find them. So this is another call, all the right calls for the length greater than 4, because sometimes you get one character right. So again, this is looking for write events in the undo log. So it could be writes to anything, writes to a file, writes to standard out. Basically write system calls. Again, it's using the Python API, so it's creating a Python script to do the work. And there's the Python script that it's created. The Python API, by the way, is mirror image of the MCP commands API. So it runs the Python script. Sped it up slightly. And here's the output. Didn't actually show the table, so I've asked it to print the table. And there are all the write calls. You can see the whereas Wooly stands out, there's a whereas Wooly written to a temp file. It's quite handy to see all the writes that your program made. And that's all for now. There's all sorts of other possibilities we could explore, including getting Claude to do profiling to investigate performance issues, but we'll save that for a later date. Thanks.